So I'm Thea, and for the past 3 years now I've been working at Canadian Wildlife Service for a landward biologist. And last summer I helped kind of design and implement a project looking at the impacts of oil sands development on boreal songbirds. So that's what I'm going to be talking about today. So, as we've seen from most of the other presentations, energy development, including the oil and gas sector, has a huge impact as a major disturbance factor in Alberta. And in particular, there's something called SAGD, which is steam-assisted gravity drainage. And this is a new method of oil extraction that is projected to increase to become 80% of oil and gas extraction. And kind of the background. So we'll get right into it. SAGD, for those of you who don't know, is an in situ extraction method to get at all the oil deposits that are below ground. And basically what you do is you pump in hot steam through one well, and it heats up the bitumen and it comes back out through the other. And why we are concerned about this is basically because of, if you look at this landscape, SAGD has all these kind of cumulative linear features, including seismic lines, roads, and then others, including well pads and industrial sites. We don't really know what kind of impact these are having on the environment, and birds in particular. But in order to understand these landscape scale factors, first we were interested in looking at the local scale impact of habitat disturbance on palm warbler species. And so what we wanted to know is, do palm warblers incorporate these disturbances into their territories? And in particular, which vegetative factors influence that choice? So our study area is the Mackay River Commercial Project. This is a in situ SAGD lease area, and I kind of put this up here to show that in ecological studies, one of the problems is all of this different habitat. And you can't tell oil companies where to do different treatments. So what we did in our study is stratify by habitat. Sorry, I'll just go back a second. And put all of our study sites within the dominant habitat in this region, which is bogs. And within that, we stratified across different degrees of disturbance. Okay, so this gorgeous little guy is a palm warbler. And we didn't select them just because they're awesome, but because a number of particular reasons. One, they're understudied species. People don't like to go out to bogs and fens, I guess. That they're specialists to this primary habitat. And lastly, that it is thought they might have a good indication of the impacts at the landscape scale of disturbances to these habitats. So for our treatments, we have survey grids that are across the gradient of disturbance from low to high. This one here is the control, and this one you can see there's roads and lines and permanent features that are impacting that habitat. So to determine habitat use, we do what's called resource selection studies, and where we're interested in looking at used habitat and how does it compare to the available habitat. These are palm warbler territories, and what we were looking at is the used points in these territories, do they differ from the available points? And examine those systematically across the grid. So vegetation, what we did is divide the vegetation into different layers, so starting from ground cover, very short shrub, which is 0.5 meter to 1 meter, tall shrub, greater than 1 meter, regeneration greater than 4 meters. And we looked at as many factors as we could within those layers, including height, density, percent cover. And so I did a number of exploratory things with my data, and got, like a lot of you from that I saw, which was nice yesterday, a lot of non-normal data and a lot of factors that I didn't really know what to do with. So instead, one thing that I did notice in my data was I tried to look at the influence of percent of cover of these low vegetation on the palm warblers. And I targeted this specifically because palm warblers are ground nesters, and I thought it might have an impact. So very small subset, I'm just going to talk about this one data table. And what this shows is each one of our vegetation plots, the dark is the short shrub, the medium is the very short shrub, and the lightest is the cover. And I put this little dot on here. This is a plot that was done at a palm warbler nest. And, oops, a little slow here. And I thought that this was really exciting because what I anticipated was that this very short shrub cover would kind of maybe be one of the deciding factors about where the palm warblers would put their nests. And then I put this dot on, which is also another palm warbler nest, and I realized that oh, they're kind of different. And I thought this was really neat because something that I noticed is this distinction here between this side and the other. And I thought it might have something to do with habitat, and then I realized that actually these plots are one observer, and these plots are another observer. And they tell you that percent cover tends to be a really biased estimate of vegetation. So we might have a little bit of a problem with this data here. So I didn't really show you anything else, but what I learned from doing all this stuff was that I have a lot of different data variables. I'm not really sure how I'm going to look at how they interact. It'll be a bit tricky, but then I might need to control for observer bias in my sets. And eventually what I want to do is look at something called case control logistic regression, potentially. And what this does is it takes those use points and it pairs them with available points in the same plot so that you can look at is there a relationship across the gradient of different plots.